Well, good morning, afternoon, evening, nighttime, wherever you maybe are, somewhere around on this lovely world of ours. Thanks so much for joining us live here today for Serverless Office Hours, streaming weekly on the AWS Twitch channel, on YouTube Serverless Land, and also via LinkedIn Live. My name is Julian Wood. I'm a developer advocate for the serverless team here at AWS, and I'm super duper happy to have two serverless experts who kindly and willingly joining us today. First of all, Diren Akkoc, welcome to Serverless Office Hours, your first time. Thanks so much for joining us. Diren, how have you come to do so many cool things with AWS?
Thank you so much, Julian. It's great to be here. Thank you so much for having us. How I ended up working with AWS staff, I actually came to Dublin to learn English, and I come from civil engineering background. Then during the COVID, I wanted to change my career path. Then after I graduated from the college, I just ended up working in fourTheorem. So I have been working with fourTheorem almost 2 years, and I have been working a couple of clients project, and also recently I have been maintaining the SLIC Watch, our observability plugin, which we will be talking about. So yeah, that's all.
Excellent. Well, you've obviously done super well. I mean, seriously, to move to another country, to learn English, which your English is amazing, and then do COVID and jump a job and then build open source tools like, wow, kudos. Excellent. Well, Luciano, it's so nice to have you as well, also from fourTheorem. Luciano, you also, I know, a podcast host yourself and do plenty of things in serverless. So yeah, what is your journey to AWS?
Yeah, first of all, hello everyone, and thank you very much for having me, for having us. Really an honor and a pleasure. So as per my story, probably a bit simpler than Diren's one, a bit more obvious. Been in IT for a while, done lots of like full stack things, worked in many companies, and in the last 5 or 6 years, I think I've been lucky to have been progressively more and more exposed to AWS, to the point that now I'm working in fourTheorem as a architect, mostly doing cloud stuff, working in AWS. So that's basically my story. But I have a little bit of a spoiler because you mentioned the podcast, and the next episode of the podcast, which is going to go out this Friday, it's actually my story and Owen's story with the other podcast co-owner on how did we started to do IT, computer science, and then eventually AWS. So if people are curious to get a bit more of that background, please check out the next podcast episode this Friday.
Well, excellent. I'm just actually looking at my screen. I was just thinking, well, you can get in contact with Luciano and Diren via their Twitter accounts. And obviously, I'm a day out. I've got the wrong logo, I've realized. Tweets are no longer birds. I should have had X's. I'm obviously way behind. So sorry about that for anybody who's worried about that. But before we get back to Diren and Luciano, let's just have a quick look back in the previous world of serverless. The last stream last week, 18th of July, Jason Hunter joined me looking at DynamoDB global tables. Proper deep dive, technical, under the hood look at it, which was super useful. Yeah, Jason was just a font of knowledge of all the kind of things you need to think of. I was super interested in how actually simple it was. There were so many things I kept asking questions about. What about this? What about this? And Jason was, well, DynamoDB is just going to handle that for you with really good architectural patterns and ways to think about, splitting your applications across multiple regions. Super useful. So that's available on our YouTube channel, Serverless Land, along with all other episodes of Serverless Office Hours over quite a while now. In terms of what's new with AWS Serverless, if you're a Lambda person or you're using EventBridge pipes, there's a support for advanced enhanced filtering. So that does things like suffix matching now. So you could match maybe on a PDF file or a docx file or something like that, and just builds out more things that you can do with your serverless architectures. And also Amplify has shrunk some of their libraries for their JavaScript SDK and improved performance with some other code changes for their auth storage, notifications, and analytics. So if you're an Amplify person, that would be super cool. Just some recent blog posts. If you're using step functions, there's a new blog post out. Really cool patterns that I love how people are building into step functions. And this is one that can exit out early of a parallel state. So using step functions for some of your workflows, and you have a parallel state doing the same thing, but you then want to exit out of it. How to handle that sounds a bit of a brain tease, but Matt has got all the information for you. On the 26th of October in Nashville, USA, we've got EDA Day, Event-Driven Architectures Day. Lots of people from myself and my team and some awesome speakers are going to be diving into all things deeply nerdy for Event-Driven Architectures. So yeah, please sign up for that. That is going to be super good. And yeah, I would suggest getting your tickets early because they are going quick and fast. So you wouldn't want to miss it. Serverless Land is our team's site for all things serverless and AWS. There's a new learning page, which has got a whole bunch of things all aggregated together. It's got information on workshops and guides and things on replatforming and migrating and building and any kind of thing. So yeah, really good place on Serverless Land. A new learning page for lots of information. Recently updated a whole bunch of workshops. I always find workshops are a great way to get hands-on code and learn about exploring different kind of things. So yeah, all categorized for different services and use cases. Super useful. And well, a slight little punt for something I've done recently is Lambda Fundamentals. So this is really at the beginning, 23-part video series, just small little short videos of literally everything to do with Lambda, from the beginning of what is serverless and how Lambda fits into the execution environment, to the Lambda lifecycle, to observability, to permissions, billing, 23 of them. So yeah, have a look at that. Hopefully that's useful if you're getting started with Lambda and scratching your head wondering what it is all about. But this week, we're talking about observability. So over to you, Diren and Luciano. SLIC Watch is a tool I spotted a while ago, actually. It sort of certainly piqued my interest because I've done a lot of observability work in my time, and making it easier is always a good thing. So what can you tell us about SLIC Watch?
I can start if you want, Julian, with the slides. We have some slides, so we can go through of them. So we will be talking about easier observability with SLIC Watch, and I don't want to spend so much time on our cover page because I really want to dive into the observability world and explore together this great world. Just I want to say, you can, for those who would like to follow along, you can see the slides via this link, and I think Julian shared the links, and they will be also available after the live event. So you can see my contact details. That don't be shy. Feel free to get in touch. You can see, you can find me on Twitter, LinkedIn, and GitHub. And you can find Luciano in everywhere. He's quite a famous person. So he's available on Twitter, LinkedIn, and many other places. And he mentioned about AWSfights.com. So it's a great website. You can find so many AWS topics. Luciano and our CTO, Oren Shenegai, are running weekly podcasts on AWS. Today, we want to talk about a typical serverless application running in production. And it's generally not simple. Even if we like the serverless, let's face it, distributed systems can easily grow out of hand. In this example, even though this is not a very complex serverless application, we ended up having over 100 resources, including Lambda, DynamoDB, API gateway, so on. So with such a system, we want to be able to know about any problems before our users do. And we can do this by applying observability. So let's see together how observable our system is. But first, we need to understand what is observability. Observability is the ability to measure the internal state of a system by examining its outputs. So if we have a good level of observability, we need to be able to ask questions from the outputs, and we need to be able to fix these problems before our users notice. So we aim to apply to this good level of observability with fundamental building blocks of structured logs, tracing, metrics, and alarms. So that's great. We have everything in the place. I mean, we have the concept of the observability, but how can we test how observable our system is? And we decided to run a stress test. We followed these steps. We simulated traffic using our integration test. We ran the test a number of times in parallel, and we ensured we exercise all the APIs with typical use cases like CRUD operations, login, logout, so on. So after a few minutes, we started to get alarms arriving into our Slack channel. And if we look at these alarms, we see different alarms from different resources. For example, we see DynamoDB write throttle events, we see API gateway availability error, and we see multiple Lambda errors. Okay, after seeing these alarms from our Slack channel, we wanted to understand how they might be correlated. And we built a mental model. So we saw API gateway is failing. That's probably our Lambda function is failing. And also we saw DynamoDB throttles. So from the outputs, this is the scenario what we can imagine in our head. So after we built this mental model in our head, our initial hypothesis is telling us, okay, we got throttled on DynamoDB write events. That is probably causing our SDK to perform multiple retry in Lambda function. And all these multiple retries causing our Lambda to timeout. When our Lambda timeouts, our API returns 502 error. So, and this makes our API unavailable for the users. Okay, but how can we validate this hypothesis? We can check the timeout causes by going to Lambda logs or metrics. We can check the Lambda error cause by going to Lambda logs as well. And we can identify the source of the 500 errors in API gateway by going to tracing with X-ray. And we can check the DynamoDB metrics by going to DynamoDB dashboards. So that's great. We know what are we gonna do. Now it is time to gather evidence. The first thing we always do, we always go to check our application dashboard, where we can see all the relevant data from our stack. Just please keep in mind, AWS CloudWatch is giving you all these dashboards, but by service, not by application. And if you want to debug them, you find yourself lots of tabs opening on your browser and checking things on different places. You might even end up finding yourself in a console hell. So believe me, you want to set up a dashboard for your application, event-driven application, to see everything is on a page like in the screen, and yet observe the whole system just by scrolling up and down rather than jumping between console windows. And also the dashboard is a great place where you can see the correlation between different metrics. For example, here we see DynamoDB write throttle events and also Lambda durations are going up at the same time. So we can obviously say they are somehow correlated, but how? Let's see together how they are correlated. Here we are checking the cause of the Lambda timeouts, and we can check them in a number of ways. They are always available in the aggregate in CloudWatch duration metrics, but we also want to look at individual requests using CloudWatch logs. With CloudWatch log insights, we can isolate individual execution timeouts and see related logs in the first image, if you can see. And we can also create query functionality with log insights. If you look at the second picture, we group the timeouts into 1 second buckets to see how many executions are taking from 1 second to all the way up to 6 seconds, which is actually our timeout that we configured for our Lambda. And here in the image, we see we have quite a few log durations, but only 4 of them timeout. And we suspect that timeouts being caused by DynamoDB table because we saw the alarm messages from our Slack channel, and we also saw on the dashboard DynamoDB write throttle events and Lambda duration were going up at the same time. So let's just try to validate that. Here,
Diren, I just want to jump in quickly because I think there's some amazing information that you're gathering over here, specifically log insights. And if people aren't using log insights, it's such a great query language. Literally anything in a log that if you're using structured logging, which you should, so much information that you can pull from that. But my sort of question to you initially is, even knowing that it was DynamoDB timeouts, I know you came up with your hypothesis really quickly. What sort of steps should people be taking to even come up with that hypothesis of, yes, I know I've got sort of 3 or 4 services? Is there sort of some prep work that people can do to, have better guesses before they start delving into some of the things? And I know SLIC Watch is obviously going to help with that, but what would your tips be for someone approaching this and trying to come up with another hypothesis that they want to test?
Yeah, of course, as you mentioned, like SLIC Watch will be great helpful, because as we saw alarms messages from our Slack channel, and when we went to dashboard, we saw all the signs. But for people who don't use SLIC Watch, as I mentioned, you can check different things on different places. You might check like the metrics, all the DynamoDB dashboard. If you saw the DynamoDB dashboard, or if you see some DynamoDB metrics are failing, I think DynamoDB dashboard will be the amazing place to check them. But how you can find this correlation, because you don't know also which other service are failing, right?
Is there. You've got to know what to look for, and I suppose that's the big challenge.
Exactly, yeah. Like when you are doing serverless work so much, you can guess, you can get the idea, because we know general service applications, API gateway, Lambda, DynamoDB. Of course, this is not everything with serverless, but we see all this correlation because we are doing serverless a lot,
Okay, excellent. Sorry, carry on.
So here we look at the DynamoDB configuration and also DynamoDB dashboard. On the left-hand side, as you can see, we configured our write capacity units too. And on the right-hand side, this is the DynamoDB dashboard. So if you have if you don't use the SLIC Watch, this is where you need to check if you are getting some DynamoDB metrics alerts. And here we see write capacity usage being breached a couple of times, and this has been causing write requests to get throttled. So this is what we expected, and this is great. We can just validate that, and let's move on to the next one. So here we look at the X-ray. X-ray gives us a picture of how these isolated components are correlated in the distributed systems. And from the view, if we check the circle around its services, and if you look at really with details, we can see different colors here. And all these colors represents the data from our service logs. And all these colors represents the amount of requests that succeeded or failed. So here we see lots of green color. So we love green because green means that request succeeded. And we also see a couple of red ones here. It means that request failed with 500 error, which is the service error. And here also we see some yellow ones here. It means that request failed, but with 400 error, which is the client error. So let's zoom into tracing and to understand better what is these errors, what is these all colors represents. And is in this individual trace, if we look at the request can reach to the Lambda, but it takes more than 6 seconds, which throws a Lambda timeout error, which actually makes sense and which we expected because we configured our Lambda timeout as 6. And if it takes more than 6 seconds, it has to throw error, right? And when our Lambda timeout, it is causing our API to return 502 error. So this is what we expected, and we can just validate that. Let's move on to the next one. Okay, here we are receiving API 500 error, and which is we didn't expect because this is not something related to the Lambda timeout issue. So but let's try to understand, like, it doesn't mean if we don't expect anything, we shouldn't look at the errors. We need to fix all the errors, right? So here we can see request can pass the Lambda without timeout issue. So that's great. But when it reaches to the DynamoDB table, it returns 400 error. Okay, so like we cannot see anything else here. We cannot say much about these errors. We need to investigate this error to find what's going on here. And that's why, where are we going? Julian, do you have an idea where we should check this?
Something in the function. Well, it's obviously got to be something in the function.
Yes. Good
yeah,
guess.
Not sure what though yet.
Okay, so with function, of course, we are going to Lambda CloudWatch logs, and after some investigation, we found the concurrency issue in our integration test. The issue was actually we were trying to update a record that was already deleted. So we weren't handling this error properly. So this was the issue. So just to wrap up, we saw all the symptoms: DynamoDB throttles, API 502 errors, Lambda timeouts errors, and API 500 errors. The problems were low provisioned write capacity with DynamoDB table, and with Lambda timeouts, we didn't configure the maximum retry in our SDK, and when our Lambda timeout, it caused our API to return 502 error, and with API 500 error, just we had a concurrency issue in our integration test. We didn't handle the error properly. Okay, for the resolution, what we did, we switched the DynamoDB table provisioning to on-demand. And just please keep in mind here, you want to add throttling in API gateway level to limit potential cost in case users might abuse your system. You don't want to get some surprise cost the end of the month. And for the Lambda timeouts error, we just configured maximum retry to 3 in our SDK. And this fixed the timeouts issue. Of course, this also fixed the 502 error. I mean, like, if there is an issue, like, it will give us as soon as possible. So, of course, we want to sometimes fix the issue, but we want to sometimes tolerate the alarms, right, in terms of cost and also for other dependencies. And with API 500 error, we just fixed the integration test and we handled the error properly in our API. So after that, we wanted to go to compare the things before all the change and after all the change. And we went to the DynamoDB dashboard. On the left-hand side, as you can see, we have different colors here. The blue one represents the consume capacity in DynamoDB, and the red one is showing throttling. So when we switched our DynamoDB to on-demand, as you can see here, even though we are receiving burst requests, DynamoDB doesn't throttle anymore. So everyone is happy. That's great. We solved all the issues. Okay, what we have learned so far. We were able to identify, understand, and fix these errors quite quickly. The great thing with that, as you saw, we didn't have to change the code to understand what was happening. And also, we didn't run anything locally. So how all of this was possible? Because we configured observability tools in AWS in advance, and we just took the advantage of the observability when we needed it. So that's great. Just let's talk about observability in AWS Native. In AWS Native, the observability tool is CloudWatch. And what CloudWatch gives you? Logs with insights. So we saw how we took the advantage of the logs insights. It's a great feature, highly recommended. You really need to use in your event-driven application. And metrics, you saw also we used metrics a lot, but additionally, you can create your own custom metrics. So that's a great feature as well. dashboards, I think you really, it's something you must have because it's a great place for observability, and alarms is also a very important thing. And CloudWatch also gives us Kinesis. This is something we didn't use. It also has great features and functionality. The first thing comes to my mind, Kinesis is using CloudWatch synthetics to give you Lambda with a headless Google Chrome browser, so you can monitor your endpoints and APIs. And you also saw we use a distributed tracing with X-ray. This is an amazing feature. You can see where is the problem. So what CloudWatch gives you out of the box? The first thing we need to understand, it is a toolkit to allow you to build observability solutions yourself. So you need to put some effort into CloudWatch to make it work for you. And metrics are automatically generated for all services, which is amazing. Lots of dashboards, but oriented by service, not by application, and 0 alarms out of the box, which is actually fair because the alarming you really want to do based on understanding your application context, like at what level you want to alert on. Do you want to tolerate some alerts? So it's up to you. So you can create alarms and dashboards for your event-driven application to get the best out of the CloudWatch. And for configuring alarms and dashboards, you need to follow these steps. You need to research and understand available metrics. You need to decide your thresholds, like at what level you want to alert on. You need to write infrastructure as code for your application dashboards, as well as for your service metric alarms. And every time you add a new service to your application or even a new Lambda function, you need to update your dashboards and alarms, and you need to make sure that you do that for each stack in your application. So I know it sounds a lot, and it is really a lot, but at the end of the day, it is really worth it to have the observability. We highly recommend you to please treat your observability as you treat your unit test. Maintain it, care and feed it. It will definitely pay you back. And observability should be your friend from day one. You will not regret it.
Yeah, I think that's a really good point. I think I really like that you look at your observability as with your unit tests, because also ideally you want to be writing unit tests as you're building your application, because you're not going to build a unit test, finish your application and then start introducing all the unit tests. Your unit tests as part of building the application. And yeah, observability while you're as a developer building your application, putting the observability in, adding the logs, adding the metrics, adding the tracing, literally as you're coding is yeah, super useful. So I like that. I like that analogy with unit tests.
Thanks. And we are lucky because there are great places that we can research and understand available metrics. If you haven't heard about AWS well-architected framework, it is a very well-written documentation, and the operational XLM pillar is the one covered observability. And when you are doing serverless work, Serverless Lens is a great place. You need to look into it, and it applies these 6 pillars. Serverless Lens provides great guidance on metrics, but you still need to pick your thresholds. So this is what infrastructure as code look like, and this is an alarm for Lambda throttling metric. So there is a great amount of work you are going to do if you are going to write those for every single Lambda function in your application, and also every single service metric in your application. So this may be preferred by some people, but I don't think so. Maybe who wants to suffer? But this is not fun at all. So, okay, we want a better level of observability, and CloudWatch is a super powerful tool, but setting up dashboards and alarms in CloudWatch requires a lot of work, and it looks like really painful. So Luciano, please help. So can we automate this whole bunch of work and yet have a better level of observability? What do you think?
Yeah, Julian, I don't know if you can switch the screen to my screen.
Yeah, certainly can.
Thank you so much. All right. Thank you, Diren, for the amazing introduction. I love the investigation story. I always like to think about this kind of problems when you're trying to troubleshoot something, like you are the investigator in a kind of a murder history and you get to solve the crime scene.
I like that.
So it might not be always fun, but at least you get to be the hero sometimes. So it can be interesting. Anyway, the point is here, we have seen that there is a lot of work that we need to do to really have all the tools that will allow us to do a good job, figure out the problem, and make our application better and better. But is there anything that we can do to kind of find a shortcut that will allow us to achieve the same things, but by putting less amount of hours in doing maybe repetitive tasks? So the idea that we got while working on with different customers and finding that we will be spending the same amount of time every time doing the same things over and over is like, can we automate some of this work? And I'm not going to tell you that we are going to be able to automate everything, because I think you still need to understand how observability works. You still need to understand what are the unique characteristics of the applications you're working on. So we are going to be automating some of the work, but of course, it's not going to alleviate the pain of dealing with observability 100%. Just keep that in mind. So the idea here is basically, because we define everything as infrastructure as code, and by the way, this is a must, don't forget to do that, always do infrastructure as code. What we are doing is that we have something that describes our application. Maybe it's one stack, maybe it's multiple stacks, but inside a stack, we have a collection of all the resources, all the different AWS components that are part of our application. So we really can take that as an input, and that's going to describe exactly everything that exists in our application. So the next step is, if we have that, can we have some kind of magic script that understands all the different things that are there, maybe Lambda function, SQSQ, DynamoDB tables, load balancers, everything else really, and start to apply all the best practices that we know exist in things like the well-architected framework. For instance, if you have a queue, you probably want to monitor if you are processing jobs from that queue fast enough. Or maybe if things are slowing down, you should have an alarm that tells you something is going wrong. You might want to check out and address the problem before it becomes too big. So the idea here is literally just that. We take the infrastructure as code, define that, for instance, CloudFormation, and have a process that look into it and magically generates stuff for us. So if we don't have any alarm or any dashboard, we can build a bunch of out-of-the-box default alarms and dashboards that are coming from the best practices that we know from different places like the well-architected framework. And if you want to do this, there is already a solution. It's SLIC Watch. It's the tool that we built. It's an open source tool. You can get it from NPN. And I'll be showing you a demo shortly, but SLIC Watch does exactly what we just described. And just to zoom in a little bit, SLIC Watch works with different tools. It doesn't work just with CloudWatch. You can use it with Serverless Framework. You can use it with SAM. You can use it with CDK. And the idea is that in all these cases, you are still defining infrastructure as code. You are, at the end of the day, you are still generating CloudFormation stacks. And if you look inside a CloudFormation stack, it's just a very big blob of JSON. So what you generally do, you take that JSON, you give it to CloudFormation, and CloudFormation is going to deploy all of that infrastructure for you, applying all the necessary changes to your application. What we do in addition to that is, just before deploying that big blob of JSON with CloudFormation, we look into it, and with SLIC Watch, we add all the additional things like dashboards and alarms for you out of the box using the best practices we just mentioned. So what with SLIC Watch, basically what you do, you are converting a very big JSON into an even bigger JSON that is doing a lot of work for you, and then you just leave it off to CloudFormation to deploy. Okay, let's stop with the talk and let's hopefully show something real, and let's pray that demo gods that everything is going to go right.
I mean, I love the automation story for this as well, because I mean, I'm guilty as anyone of talking about, observability and all the kind of things and listing. I mean, I've done talks before. I've done, listing of these are the metrics you should be watching for Lambda, and these are the metrics you should be watching for API Gateway and Dynamo and a whole bunch of other services. that list does grow, and you're sort of not entirely sure. And then, we recently for Lambda, for example, we added some async metrics. So you're like, okay, well, do I need to use those or not? So yeah, this whole automation around the metrics gathering and those alarms and dashboards gathering, I think is super useful, because otherwise I appreciate the well-architected framework you've got to delve through, and the documentation you've got to delve through. There's super powerful metrics, lots of stuff to monitor. Which one should I use? I love the automation approach.
Yeah, and that's literally the same premises we started from. We realize we are not always going to be consistent. So if we can automate something, there is a chance that we'll do a better job and we'll save some time as well. Okay, so fingers crossed. Let's see what happens. Right, I do have here a project that is actually something you can get by just looking into the SLIC Watch repository. SLIC Watch is built as a monorepo, so if you just go on GitHub, you'll find the core library, all the different components for CDK, Serverless Framework, and then there is also this kind of demo project that you can use just to illustrate how you can apply SLIC Watch to any kind of medium-sized serverless project. And it doesn't have to be serverless, to be honest. We just happen to do more serverless than other kind of applications. It really needs to be just an AWS application using infrastructure as code. Okay, so here, what do we do? Here I'm using Serverless Framework. The reason is just because using Serverless Framework is just a little bit easier for the demo, because we don't need to provision a custom CloudFormation resource. With Serverless Framework, we can just use a Serverless Framework plugin, and it's going to do all the magic stuff for us that way. So it's just a little bit faster. But if you want to use CDK, SAM, or barebone CloudFormation, you can still use SLIC Watch. There is just an extra step, and you can find the details in the README. So if you are familiar with Serverless YAML, we can have a very quick look through this particular project. And what we do is basically we are provisioning a bunch of resources. There are some Lambda functions, and then we have a step function. We do have, there is a step function. We have another file with a bunch of resources, so I'm going to switch there. But it's just to show you that this is a fairly sizable project with lots of different types of resources. So Kinesis, S3 buckets, DynamoDB tables, and SQS queues, and so on. So what we want to do is, initially here, I do have already the code that is needed to enable SLIC Watch, but intentionally I'm keeping it disabled. So we're going to proceed with a deployment and just see what do we get from this project. And without SLIC Watch, what is our posture in terms of observability? So if we want to deploy all of this, let me just make sure I'm still logged in. We're good. Okay, so what we can do is npx serverless deploy. And because this is going to take a couple of minutes, I believe, meanwhile, we can discuss, actually, when we get to the first phase, we're going to switch off into the CloudFormation console just to see the deployment happening, and we can talk through the different resources that are being created. But meanwhile, I don't know if there is any question we can try to answer.
Yeah, we did. Well, thanks. The Tech Guy 21. Yeah, thanks for joining again, Tech Guy. I did mention about some of the metrics and everything documented in the well-architected docs, or what metrics to what metrics to monitor. Jeepers, that's a tongue twister if I've ever heard one. And so I have done a link over here. You could read it on the screen. So that basically is part of the serverless application lens of the well-architected framework, and it has some of the metrics that you can do. And I think it's got Lambda API gateway, a couple of others, even SQS Kinesis and all these kind of things. Obviously, it's not going to tell you the limits and the triggers you need to use for that, because that's going to be application specific. But that's at least a start. So hopefully that helps with the information as well. But also remember, we're talking. In fact, I'll roll back slightly. One of the things I love about serverless is how your application and your infrastructure really become the same thing. And, I worked in traditional infrastructure backgrounds before, where you used to monitor your infrastructure, and then, a whole app team used to monitor their applications, and in a way they were completely different. But one of the whole benefits of serverless is how that really comes together. And so actually what SLIC Watch is doing is monitoring your infrastructure, which is the basics of your application. It is how your database is working. It's how your queues are the throughput of your queues, it's your Lambda function timeouts and everything. And that is super important. But also remember that there is specific application metrics and things you want to be putting into here. And the great thing is they can be all put together. So you can create CloudWatch metrics and CloudWatch logs using hopefully the embedded metrics format, and stick your business metrics and your business metrics, your things updated or orders received or orders canceled, deleted, sales figures, whatever. You can put that within along with your infrastructure application metrics, and they're all available together. You can then graph and do the dashboards and everything as that as well. So I'm sort of messing up a bit of my explanation. I need to get this a bit better in my own head. But the idea is that your infrastructure and your application with serverless is really tied together, and use that as an opportunity to combine your metrics together, because then you've got real insights into how business is happening, not just for example, how many Lambda errors you're having or API gateway errors are happening, but you can also have latency for your front-end application or how many orders you're receiving. And when you can correlate that with some of the infrastructure metrics, then your observability starts to fly.
Awesome. Yeah, definitely agree with all the suggestions. So
meanwhile, we do have a question from Avinash. How SLIC Watch is better than the automatic dashboards created by default? So as the SLIC Watch writers,
I'll keep this one for the next deployment, because we'll have to wait another probably minute, but it's
Avinash
a great
will be
question.
back with you.
All right, so let me switch over to the console. So what we did is we should have here a new stack being deployed. If we look at the stack, we have this test project. And if we look at resources, there should be everything we described before. So we have API gateway, we have buckets, DynamoDB table, queues, and so on. Now, the thing is, if we want to understand how are we doing in terms of observability, what we can do, we go to CloudWatch and we go to dashboards. And we can see that by default, there isn't really any application dashboard that is being created for us, even though we have a stack that describes our application and how different resources are correlated together to create this application. We can go to the individual services. For instance, if we go to Lambda, let's go here. Let's take, do we have a Lambda? Let's see. We do have a Lambda here. And if we go to Lambda, we can go to the monitor section, and we will have, for instance, logs, metrics, and traces. But we are looking specifically at this one Lambda. This is what Diren mentioned with console hell, that if you're trying to troubleshoot correlation between different things, you probably end up opening a bunch of these different tabs and then constantly switching and trying to make sense of different things that you are seeing. Instead, if you have one dashboard, you can kind of build the things that you care about and put them all in one place. And that's a very valuable tool. But the problem is right now we're not getting that out of the box. So we'll need to spend time and build it ourselves. Similar for alarms. If we look at all the alarms, there is nothing. We'll need to create our alarms by ourselves. We'll need to understand which ones make sense. And if we are using a queue or Lambda or DynamoDB, Julian, as you mentioned, there are some recommended things. We will need to implement them ourselves, even though they are not necessarily application specific, but they are just best practices that we can apply by the kind of service or resource that we are provisioning. Okay, so the next step is, let's take this application as it is. We don't need to change anything. We just need to enable SLIC Watch and deploy again and see what happens. So to do that, really what we need to do, if we are using Serverless Framework, is to just install the plugin, and then we can just enable the plugin here.
Luciano, I don't know if you just save the output from the Serverless Framework, because we might want to also show the how they can code all the things,
That's a great shout out. So what we can do also to compare, well, to see exactly what SLIC Watch is doing at the CloudFormation level, we can save here the template that was generated for the previous deployment. And then we compare it with the one that is generated after we enable SLIC Watch. So that's a good shout out. Thank you, Diren. So let's copy that. I actually have it here. So we have this no SLIC Watch template is basically the one that we just deployed before. Now we're going to enable SLIC Watch, deploy again, and then compare the two templates just to see how much stuff was generated for us. Now, I was saying that you just need to enable this, and that's going to be enough. Like, there is a standard set of defaults that you are good to go. You can just use them. But if you want to configure something, you can add more configuration. And here I just have a few examples. So I'm just going to enable all of this. And one thing that is really recommended that I'm not doing right now is you can configure your alarms to go to an SNS topic. And that's generally something you use, for instance, to send your alarms to, I don't know, your Teams channel or Slack channel, or maybe, I don't know, your operational tools. I'm not doing it right now just for simplicity of the demo, but you just need to have your own SNS topic created, mention it here, and then your alarms will be automatically linked to that SNS topic. Now, the other things you can do, you can change some of the defaults. For instance, here you can change some of the thresholds for Lambda. You can enable and disable things. You can do it for SQS and so on. But you can also do it at the Lambda level. So for instance, here, what we are doing, we are saying, I want to change a specific threshold for this Lambda, or for this other Lambda, I want to disable the dashboard because this is a Lambda that maybe I use only for testing. It doesn't make sense for me to have it in the live dashboard. Or I think there is something else here. Yeah, for instance, here we want to disable all the alarms for this particular Lambda because, again, maybe it's not a Lambda that we expect any alarm from. Or maybe it's just going to add noise if we enable alarms for this one. So you can just see here how you can configure at the kind of global level or more granularly for specific Lambdas.
And Luciano, I know you are showing it in the serverless framework, but how does one add it for SAM or CloudFormation?
Yeah, you can use.
I think you said
you can use the metadata section, okay. And we will have some examples as well in the README, and you can see actual use cases on how to enable or disable or change configuration for certain things.
Okay.
Okay, so at this point we can deploy. I think that's next step, and I promise to answer a question, I guess, meanwhile, while this is happening. So the question was, how SLIC Watch is better than the automatic dashboard created by default? And I don't want to be mean, but by default, you don't get any dashboard. And by that, I mean any application dashboard. So what you get is the dashboards that you can see in every resource. So for instance, if you go to a Lambda, you'll see some dashboards there specifically for that Lambda. If you go to SQS, in the monitoring section, you'll see some other dashboards specifically for that queue. So kind of the way that I could answer this question is that with SLIC Watch, you get an application dashboard. And that's, in my opinion, intrinsically better when you're trying to troubleshoot an issue at the application level, because you can see correlations. Like in the example that Diren showed us before, we were seeing that there was some issues, some throttling in DynamoDB. And at the same time, at the same point in time, if we were looking at our Lambda duration, we saw that there was an increase in the duration of that Lambda. And this is something that it becomes more and more difficult to spot if you have many resources and you think you need to open many different tabs and try to make sense of them all together. So hopefully this is answering the question, but feel free to ask more.
And I mean, also with CloudWatch, you do have cross-service dashboards where you can, the thing with that is that's going to show everything within an account. So, if you've got a busy account, that's going to be super difficult, and you're going to see your X-ray, your service map is going to be super busy. You can use a resource access manager, and that's quite useful, which uses tagging. So it does tags individual resources, and then you can sort of corral the view, simplify the view to just look at all those things with tagging. But that's just on the viewership kind of thing. This is now actually alarms and dashboards, which is going to be specific to your application. There are some auto-generated ones, but it's not going to be as specific to your application.
Mm-hmm. I actually didn't know about this tagging feature, so that's something good for me to take on after this event. Okay, so now we deployed. Let's go back to our dashboards and see what happens. So now we have an application dashboard, and this was automatically generated for us by SLIC Watch. Like, we didn't have to spend any minute just even thinking about, okay, how do I even start creating this dashboard? What should I put in it? There is something that was created for us. Now, if you look here, it's going to be a bit crowded because there are many resources, and it's basically adding things that could be interesting for all the resources that we are using. So for instance, we have API gateway, so we have dashboards for 500 errors and 400 errors. We have latency. We also have step function, so we can see the execution of that step function, and a bunch of other things that they are all coming from the best practices we described from the well-architected framework. Now, here is a bit boring because we don't really have any data. So because we just deployed this application, there is no real user interacting with it. So it's not really populated, but you can imagine that the data will start to flow if this application was actually being used. And this will be a single pane of glass where we can go to see how things are actually behaving. The other thing I want to show is that if we go to all alarms, remember this was empty before. Now we have quite a few alarms that are being created for us by default. And there will be things like we can see the status of a queue, if there are jobs that are being accumulated in that queue. We can see Lambda failures. We can see Lambda duration if it's getting close to the limit for that Lambda before it times out. And we will get alarms for all these things. So I think at this point, what we can do is to another way to visualize all of this work that was done for us. Imagine that you wanted to do it yourself. You don't want to use a third-party tool. You still want to do everything manually. How much work there is to do all these things manually. And what we can do is we save the template that was generated before adding SLIC Watch, and we can compare it with the latest template that was generated after we enabled SLIC Watch. And if we compare these two, let's see if I remember how to do it here, compare selected. What we can do is basically here we are doing a diff between the two, and all the green there is basically stuff that was added automatically by SLIC Watch, and we didn't really have to think about that. We didn't really have to write all of that code. And just to give you a feeling for it, let me zoom in here because we are only interested in the green part. If we scroll down here, you can see that we have a dashboard, and this is the application dashboard that I was showing before. And the interesting thing about this one is that creating dashboards in CloudFormation is a bit of a pain because you end up with this kind of nested JSON. And you can see that this nested JSON pretty much goes on and on forever. You wouldn't want to write this manually, right? Maybe you can use other tools, but I think you still probably want to use some kind of tooling because writing this manually is going to be very, very error prone and quite boring, frankly. So similarly, if you create alarms, it is a little bit nicer, I think, to write alarms because you're not writing this kind of nested JSON or JSON embedded in JSON. It's more kind of one object with its own structure, but it's still quite verbose. And if you want to create many alarms, like it will take a bit of time, and getting it right the first time is going to be tricky. So again, you probably want to use some kind of module or some kind of other automation. It doesn't necessarily have to be SLIC Watch, but here it goes to show that it's not an easy feat to just write this stuff from memory, and to do it every single time you are creating new resources or you are changing something in your application. So I'm gonna go very quickly back to the slides just to wrap up. I already mentioned that you can use SNS, and SNS is great to basically integrate your alarms with other tools, because I think your alarms are only good if somebody's looking at them. If they are just firing and nobody's looking at them, it's like you don't really have alarms, right? So you definitely need to integrate those somewhere where you are actually getting notified straight away and you can immediately action those alarms. We use Slack a lot. We also use Teams with some of our customers. And there is AWS Chatbot is actually an amazing integration you can use to basically take the alarms coming in SNS and deliver them in different places, like different kind of chats, like Teams or Slack. But if you want something more structured, you can either integrate it with something like Ops Genie, where you will have people on call, there will be a rotation, and there is an entire procedure to make sure that every time something fires, it kind of creates a case, and that case needs to be properly actioned and resolved properly. As I mentioned, SLIC Watch is fairly configurable, so you can basically enable, disable anything. You can change all the thresholds that are configured by default. So it's not really limiting what you can do. It's just a good default starting point. And then if you want to fine-tune different things, you can add the configuration that you need. And this is just a quick summary of what we did today with Serverless Framework. It's going to be slightly different if you use CDK, SAM, or barebone CloudFormation. But basically, for serverless, you just install a plugin, you update your serverless YAML, you can add a bit of optional configuration, you deploy again, and it's going to do all that extra stuff for you. Now, you might be wondering, okay, but I'm not using CloudFormation at all. Maybe I'm using something like Terraform or Pulumi. Can I use SLIC Watch? Well, in theory, yes, because the concept still applies. You still have a description of your application using infrastructure as code. So you could take that and expand it with some kind of automated script. It's just that this is an open source project and there is only so much time that we can spend on it. So we haven't built integrations for Terraform, Pulumi, or other infrastructure as code tools. But it's an open source project. So that means that if you are interested in contributing, you can do that. Come to our GitHub, contribute, send issue, and we will be extremely happy to have people contributing to the project and making it better. What do we think we should be doing next? We don't support all the resources that are available in AWS. There are still things that we haven't really implemented all the best practice rules. For instance, better dashboards is something we could do. We could add support for CloudFront or Lambda at Edge, RDS, and more. We have a bunch of issues that are already open in our project repository. So if you want to contribute and you don't know where to start, just check the open issues. And there are some ideas there for things that can be improved. And that's really everything we have to share for today. I think if I want to summarize our main points is that observability is a must, especially if you're building event-driven system or distributed systems in general. Today, you need to think about observability as an integral part of every feature that you're building in your application. As we said, you think about tests this day as a good default. You write a feature, you write tests. You should also think about, I'm writing this feature. What are some good logs, some good metrics, some good alarms that I should put into place from day zero for this feature, not as an afterthought. And observability can save you from hundreds of hours of blind debugging. Like I remember before learning about observability, I was always trying to reproduce bugs locally, and then your local environment is always different from what you have in a remote distributed environment. Sometimes you manage to reproduce the issue and fix it, but sometimes you just can't. And then you end up kind of guessing and doing changes and hoping that those changes are actually going to fix the problem, but you don't truly understand that problem. So I think if you do spend your time and put the effort into learning about observability, you will be in a much better position to figure out when things are going wrong, what's actually going wrong, and how to fix the problem. If you are in AWS, CloudWatch is basically the standard tool that you can use to do everything you need for observability. I know that there are other tools that you can use, other vendors, but I think you still rely mostly on CloudWatch as the main point that gives you all the necessary data. So I think it's just good practice to learn about CloudWatch and use it. And finally, if you want to use some automation, SLIC Watch is one tool that can help you to take some of the pain of configuring all these things away, and it will give you a good starting point where you are already applying all the standard best practices, and then you can focus on the things that really matter for your application, like specific details that make sense for your business logic and for your application. You still have control and flexibility, so if there is anything in the default rules that you don't like, you can change those, you can disable things, and just keep the things that really matter for you. So I think that's everything we have. I don't know if we have time for more questions.
I think we're running up, but I just want to say that is super amazing. I love just everything, how quickly it is to set up, automatic dashboards, alarms, everything, just super useful. So yeah, really want to say thank you for all the time and effort that you put into it, because I know it is a lot. Just before we say goodbye, in a few seconds, just same time, same place next week, we're talking step functions, versions, and aliases with Corey and Shiv. So if you wanted to safely deploy step functions, this is going to be super cool, and they're going to have a cool demo as well. Don't forget, I did mention serverlessland.com for everything about serverless on AWS. That's your sort of one-stop landing shop for everything you're going to need. Well, Luciano and Diren, I appreciate all the hard work that you put into here. Oh, one thing before I say goodbye. I did mention earlier about Resource Access Manager. I got the wrong service. Sorry about that. It's actually AWS resource groups I was talking about, where you can combine different resources together and you can use them in CloudWatch and Service Lens and other things. Sorry, faux pas on my side. I got the wrong service. That's I'm sure that's unheard of in AWS.
I think I mentioned a few times CloudWatch and CloudFormation and swapped the names. So
there we go. It's going to happen. This is live. We're going to talk about it. Diren, Luciano, super appreciate you taking the time today. And yeah, please head over to SLIC Watch, use it, contribute. It'd be great to make this even better for everybody in the community. Thank you very much. Bye-bye.
Thank you so much.